Exercise 40, question number 8. Rearrange this function, a squared over x squared plus b squared over y squared equals 1 for x. I'll run through this solution. There's a couple of ways you can do it, so we'll look at both ways. And then I'll leave you asking you to do the extension question, which is to rearrange this function for y and then rearrange it for a. So let's have a go at the question. So, well, one way forward with this is to multiply both sides of the equation by x squared to get rid of the x squared term in here, which is underneath. And then when you've done that, multiply both sides by y squared to get rid of the y squared underneath, or in the denominator in the second term. So then you would have something where there was no fractions, and that might make life a lot easier. The other way to go about it is if we look at the term involving x, which is this term here, I could start off by subtracting this term from both sides and then going from there. So let's try multiplying through first of all by x squared and then by y squared and see what we get. So you could have a go at this yourself, pause, and then maybe have a look at the solution afterwards. So multiplying both sides by x squared, I get a squared, because multiplying by x squared has got rid of the divide by x squared, plus b squared x squared over y squared equals x squared. Now let's multiply both terms by y squared, or both sides rather, by y squared. So we get a squared y squared plus b squared x squared equals x squared y squared. So now we have a situation where there's no denominator. Remember, we're after getting x on its own, so the next step is to get all terms involving x on one side. I recommend get them on the left-hand side, because eventually we want x to be on the left, and then all other terms on the right-hand side. So you could go from there, see if you can work it yourself. So subtracting x squared y squared from both sides, we get a squared y squared plus b squared x squared minus x squared y squared equals 0. Now subtract a squared y squared from both sides, so I get b squared x squared minus x squared y squared equals minus a squared y squared. Okay, there's a couple of ideas in my mind going now. One is to factorize. Take x squared outside the bracket on the left-hand side. The trouble is this minus a squared y squared on the right-hand side here. If I were to multiply every term by minus 1, then I'd get rid of that negative on the right-hand side. I would still have a negative on the left-hand side, but it would be the other term. Because if I multiplied b squared x squared by minus 1, I'd have minus b squared x squared. If I multiply minus x squared y squared by minus 1, I get plus x squared y squared equals a squared y squared. So that right-hand side now is not negative. Now when I factorize, I'll take x squared outside the bracket, I'm going to get minus b squared plus y squared. So I put the y squared term first and then minus b squared equals a squared y squared. So hopefully you can see now that by multiplying through by minus 1, I've actually got rid of some of the negative signs, which helps. So now, having factorized, I can then divide both sides by that term, y squared minus b squared, to get x squared on its own. Over y squared minus b squared, that term. And then finally, square root both sides to get x. So x equals the square root of all of this a squared y squared over y squared minus b squared. When I square root numbers, I can actually square root top and bottom. If we look at an example, if I want to know what's the square root of 9 over 4, then that's the same as the square root of 9 divided by the square root of 4. I can split the square root like that. So that turns out to be 3 over 2, which is 1.5. You might like to check that the square root of 9 over 4 gives the same answer. So we can use that idea here to simplify this a little bit. So x equals the square root of a squared y squared over the square root of y squared minus b squared. And you can see why this helps, because the square root of a squared is just a, and the square root of y squared is just y. So that means that x equals ay over the square root of y squared minus b squared, which is the answer in the text. Okay, so now let's have a look at solving this problem the other way. So going back to the original function, there it is. Do you remember a second way to go about doing this was actually to start off by subtracting the second term on the left-hand side from both sides. So I get a squared over x squared equals 1 minus b squared over y squared. Now, at this point, we need to think of another little algebraic method that we can use. So to show this works, if I have a fraction on one side, say 2 quarters equals a half, if I to invert both sides, then I get 4 over 2 equals 2 over 1. And that's still true. So if I've got one fraction on one side and one fraction on the other side, I can invert them both. And if you look at the problem we have here, the x squared is underneath. So if I were to flip that fraction, I'd have x squared over a squared, which would be really handy. The trouble is that although that's true, if I flip one fraction and then the other fraction, it's still true. A quarter plus a quarter, that's a half. However, if I were to invert all of these fractions to get 4 over 1 plus 4 over 1 equals 2 over 1, that actually is not true. So I can only do this little trick if I've got one fraction on both sides. So the trouble here is that looking at this, I haven't got just one fraction, but we can make it one fraction by making this a common denominator. If I take this 1 and make the denominator there y squared, I can make it into one fraction. So y squared over y squared equals 1 minus b squared over y squared equals a squared over x squared. So this little algebraic trick means that I can now write this as y squared minus b squared all over y squared equals x squared over a squared. So I can invert these two fractions now. I can invert these two because I've only got one fraction on each side, and this is not an uncommon little algebraic trick to use in problems like this, so it's worth seeing it. So now a squared, sorry, I had here, hadn't I? I'd already flipped it by mistake. So a squared over x squared equals that. So now I invert both sides and I get x squared over a squared equals y squared over y squared minus b squared. Inverting both sides. Got ahead of myself a bit there. So now just multiply both sides by a squared, and I've got that x squared equals a squared y squared over y squared minus b squared. And then we're at the same position, finding x, we square root both sides, and we would end up with the same answer. Okay, what I would like you to do now is to take the original function, which is this, a squared over x squared plus b squared over y squared equals 1, and rearrange it for y. So that's almost exactly the same procedure as we've just been doing. See if you can work that through. And then slightly different, rearrange for b. At the bottom of the slide, I'll just put the solutions. I won't go through the working for these, but I'll just put the answers that you should be getting at the end. Okay, here are the answers. Y equals bx over root x squared minus a squared, and b equals y root x squared minus a squared over x. That second one might be a bit awkward to get your answer to look like that, but I'm sure you can do it.